Hey everyone, thank you for coming to my second talk at LayerOne. So I spoke last year as my first talk at a big conference, and this is my second. But today, what I'd like to share with you is it's a little bit of story time, a little bit of primer to Let's Encrypt, but it's mostly about what I consider to be the best way to automate getting certificates with the DNS challenges. So if you're not familiar with me, my name is Davie, and I'm a network engineer. I've been an InfoSec adjacent for more than 15 years, being involved in different communities like ShellCon, Reverse Shell Corp, and the Western Regional Cyber Defense Competition. My main hobbies are going to be 3D printing and just managing my home lab. And if you'd like to get a hold of me, the best place is going to be on the LayerOne Discord. I'm just @_Davie. You can also find me on Twitter, but I'll probably be 6 months until I get back to you. So story time is basically, for the longest time, I was automating certificates by having an Nginx proxy manager instance just open to the internet to get get free certificates automatically. And it was kind of handy because I could access it from anywhere, but I just kind of grew out of that and wanted to do it a better way. But the biggest challenge to that is that I was hosting my DNS with Google domains, which at the time has never had an API. So automating it through DNS wasn't really possible if I stayed with Google domains. Furthermore, wherever I was able to automate this, I'd have to put some sort of credentials on disk, usually to a DNS provider. And it just felt very gross to put some sort of privileged credentials on disk to just to automate this, and then potentially have those being compromised and scraped and taken away. So I set out looking for a DNS provider with the ability to do per record scoped API tokens, so that each record had a different API key, and you'd be able to set that up for each and every domain that you want to get a certificate for. And right when I was looking for this, I found the perfect solution, which we'll get to in a little bit. But just in case there's anyone here who's not familiar with Let's Encrypt, it's a nonprofit security certificate authority, and it provides free TLS certificates to anyone who wants them, whether you're a single person or you're a big company. Literally anyone can have it. And they've been around since 2014, founded by the Internet Security Research Group, which was originally started by Mozilla, the EFF, University of Michigan, Cisco, and ACME. These days, they have hundreds of sponsors and funders, and their basic mission statement is just to provide a better internet by everyone should have security or certificates. So Let's Encrypt, the only way that they operate is through domain validation, which means that you prove control over a domain, a specific FQDN, and they'll give you a certificate just for that certificate. Now, by design, certificates expire after 90 days, and this is one to limit the exposure if a certificate is stolen from a server. It's only going to be valid for that short period of time. But the other thing is that it encourages automation, because if it's happening every 60 to 90 days, that's a pain in the ass, and so you should be automating this. You shouldn't be doing anything automatic or manually and either having your certificate expire or going with something that's theoretically less secure. Now, some certificate authorities, when you're signing up for a certificate, you sometimes have an option to check a box and say, oh, I want you to give me a key, which means that they've generated on their side and then they're pushing it to you. Let's Encrypt doesn't accept that. They don't offer that at all. So your private key will only ever stay on your server where you've generated it. And Let's Encrypt kind of got started by working with another certificate authority to sign their intermediate certificates or sign their root certificates in a way that allows existing browsers to kind of transitly trust their certificates while they were getting established and working towards getting their certificates in the browsers and mobile devices and operating systems over the last 10 years or so. These days, it's widely trusted, so any modern device, any modern operating system or browser is going to have their root certificates in there. And I think at this point they're doing direct trust, no more cross-signing. I think their last cross-sign is expiring soon, maybe in September. So And just for people that might not be familiar with some of the vocabulary that I'm going to be using, the most important one is going to be ACME, which is the Automated Certificate Management Environment. And this is the protocol that Let's Encrypt and other CAs are using to do this fully automated domain validation and certificate automation. The ACME client is going to be a piece of software that you control. This could be either some sort of binary or a script, or like built into your web browser, I mean, your web server or proxy or load balancer. And then the ACME challenge is going to be a random token that's generated by Let's Encrypt and given to you. Then you need to go and put that in a specific spot so that Let's Encrypt can validate that it's where it needs to be to prove domain ownership. An A record is going to be a DNS record that when you're a DNS request where you ask for a name and you get an IP address. A C name is going to be asking for a name, getting another name, which then will eventually go to another IP address. It's kind of like a forward. A text record, a TXT record, these are free-form texts, but depending on the application or protocol that you're working with, they'll have a certain format. And so ACME will use this by, you put the token in a text record field. SPF, which is a Standard Policy Framework, they have their specific format that they use text records for. Or like Google will give you a token to say that, okay, well, you can create a G Suite account with these email addresses because you own that domain. An NS record is a name server record, and this is how you can delegate an entire subdomain to like another server or another set of servers. And then finally, that FQDN that I mentioned, it's the fully qualified domain name. That just means it's the server name, so like www, and the domain of example.com is all in one, the fully qualified domain name. Now, there's currently 3 types of ACME challenges. The easiest one is going to be HTTP-01. This is where the ACME client will reach out to Let's Encrypt, say, hey, I want to do the web challenge. I'm available on this domain. And then the Let's Encrypt verification server will reach out to that server on port 80 specifically, on only port 80, and look for the challenge token. It's very easy as long as your server is public on the internet because it's basically just kind of works out of the box. The DNS-01 challenge uses DNS. That's what we're mostly going to be talking about, so we'll talk about that in a little bit more detail. The TLS ALPN1 challenge is similar to the HPO1 challenge, but it operates over 443 and requires specific web server support. I don't think it's widely used. I've never personally used it. And if you're looking at older docs or older talks, then you might see the TLS SNI-01 challenge, which was found to be insecure. So it was deprecated and removed. Basically, just forget I mentioned it. So that HPO1 challenge, what Let's Encrypt will do is do a DNS lookup of the site's A record, get that IP address, connect to the web server on port 80, and then it's looking for this specific file. It's going to be rooted at the root path of your domain. It's going to be .wellknown /.wellknown / acme-challenge, and then a token file. And again, this web server needs to be open on port 80 so that Let's Encrypt can do this verification. But it's going to be the easiest way to do any sort of authentication because it doesn't matter, where you're hosting your DNS. Doesn't matter where you're hosting. As long as that port 80 is open, it'll work. And kind of the one big drawback is going to be that you won't be able to get a wildcard certificate on this. And the wildcard certificate is a certificate that has subject names of star.example.com, which means that it's valid for anything under example.com. And so you specifically can't get those with the HPO1 challenge. So the DNS-01 challenge type. This is different in that Let's Encrypt doesn't connect directly to your server. It goes through your DNS records. So when you get that challenge token, you then have to go and you put in a TXT record. And it needs to be _acme-challenge and then the FQDN. So in this case, acme _ acme-challenge.www.example.com. And at first glance, this might look like you have to do this manually. You have to, every 60 to 90 days, you go in and you get a new ACME challenge token. You put that in your DNS records, and then you rerun the script, and you get another certificate. But ideally, you're going to be automating this. And ever since the DNS-01 challenge was originally conceived, the automation was based around connecting to your DNS hosting provider. So if you're using GoDaddy or Namecheap or Amazon Route 53, like that you would have to go, or that you would put some sort of either credential or API token in your automation scripts, and it would connect and do all the records for you. And one great thing about this is that it doesn't require opening any ports to the internet. So you can use this either on like private corporate internet connections or private networks, like an internal corporate thing, or if you're just like in a home lab and you're not exposing your services to the internet, you can kind of delegate the challenge to the DNS. But there are a little bit of drawbacks. And in my opinion, the biggest one is going to be that the DNS credentials that you're storing are going to be, they need to be stored on disk. So, whatever that password is, password or API token, and whatever privileges it has, if that server gets compromised and someone scrapes that config file, they now have those credentials. And in a lot of cases, depending on the DNS provider, it's going to be a username and password, which has two things related to 2FA. Either there's going to be some sort of bypass that like the API doesn't require two-factor, so what's the point of having two-factor? Or it won't work because you have two-factor, so you have to make sure that that's disabled for when you're like logging into their web portal. Or it's going to be an API token, and that API token, depending on the DNS provider, may be functionally equivalent to your password. So, like in some cases, that API token will allow them to change your password, or like allows you to change your password on your normal account, or like create VM instances or delete S3 buckets, like horrible, terrible things. And so hopefully we're using API tokens, and that they can be limited to like only DNS records and like not other types of services that are part of the cloud. Or even better, like a specific DNS zone. So like if we have multiple DNS zones, but we're only automating certificates on one of them, we can limit it so that API token is only that domain. Or even better would be saying that API token is good for only certain records, or record types, like specifically the TXT record. But in general, like it's going to getting that granular is only going to apply to providers that have like a strong IAM implementation, like AWS or GCP, that you can define custom policy and get that granular. And so I've mentioned a couple names, but just kind of to clarify like what some of these problems are is like, I mentioned Google Domains, which is where I was hosting my DNS for quite a while. They never had an API. Now they've been rolled into Squarespace, so RIP to them. GoDaddy had an API that everyone was using for quite a long time, but just recently they said, if you don't spend enough money, no API access for you. Namecheap, so I use Namecheap for some of my domains, and they have one API key for your entire account. You can't get a second one. You can't change what permissions it has. It's essentially the equivalent to your username and password. So you can register domains, transfer domains, add users that have access to your account. Not terribly great. Linode and DigitalOcean are fairly similar in this regard, in the next regard, in that you can create custom API tokens, and they're going to be limited to. You can check a box and say that's just limited to domains, and so like it won't be able to modify your your droplets or your nodes or anything. But it's going to be an all or nothing thing for DNS. It's every zone that you have on your account and every record inside those zones, you'll be able to modify anything. Where we start getting a little better is going to be Cloudflare, and you can specifically create an API token and say which domains that API token is going to be good for. But again, it's an all or nothing within this domain, so any record, if it's where your website points or where your mail records point, it's still going to be accessible to this one API token. And then AWS and GCP I have less experience with, but I assume that they're similar to Cloudflare, where the permission is going to be checking a box, is it what domain or VM instances, but you can probably also limit it to just specific zones. I don't know if you can do specific records. But if you were able to do specific records with AWS or GCP, you'd have to write like a new custom policy or role for each record that you're setting up and create new API tokens, and it could be a pain in the ass to do that at a big enough scale. But there is some hope, and the only thing that I found that is almost getting to this point is a recent announcement from Cloudflare Enterprise that says their new product called Foundation DNS that's only going to be available to their enterprise customers may in the future support per record scoped API tokens and user permissions. They didn't say when this is going to come out. They didn't necessarily guarantee that they'll do it, but it will be an interesting improvement to their offering. If you're an enterprise customer or if they eventually roll this out to their free services. And I really wish this was longer, but of all the major players that I'm aware of and that I've looked at, none of them support anything better than what I've listed. So kind of a quick review of the different challenge types. HB01 is going to be very easy to automate. It doesn't require special support from your DNS host. It doesn't require storing any API credentials on disk. But we see that it's a little bit less flexible in that you can't, it's going to be a little more difficult to set things up on servers that are not accessible from the internet or services that aren't specifically web services. And we still can't get wildcard certificates. DNS 01 on the other hand is going to be kind of the opposite, where it's a little bit more difficult to set up, but we get additional features kind of out of the box and easier with that. So just to recap, kind of the requirements that I've kind of built up are going to be that we want to limit privileges to only DNS updates. We want those DNS updates to be only text records. We want unique credentials for every subdomain. And we don't want to care who our DNS host is, what API they have, how their API tokens are scoped and distributed. And then we want to make sure that we maintain that support for getting wildcard certificates. And that's where ACME-DNS comes into play. This is a free and open source project written by, probably going to say this wrong, but Juna Hoikla. And so it's written in Go, and its one job is to provide, to answer the text record challenges for ACME. And it has a RESTful HB API for updating this. And the cool thing, in my opinion, is that when you want credentials from the ACME-DNS service, you just do a simple curl, and you get randomized credentials supplied to you. And then what you do is you take a CNAME in your domain, and you CNAME your auth challenge to the domain that they give you. And I'll show you this in a moment. But and then built into the ACME-DNS 01 protocol is that when you're doing a certificate request, if Let's Encrypt encounters a CNAME on that auth challenge domain, it'll follow it to wherever it points, and it'll check that record for the text record. So by being able to do that, we no longer need to have support from our DNS provider. We now have kind of a dedicated, purpose-built DNS provider that is answering those DNS 01 challenges for us. And so I mentioned like the simple. Using ACME-DNS is super simple because you just do a simple curl or whatever library you're using and whatever software ACME client will basically do exactly this, where you get this JSON blob that contains a random username, a random password, and a random subdomain. And then this full domain value right there, that's the value that you're going to put in your DNS as a CNAME. And so it just forwards it to that service. So, yeah, so you set up the CNAME value, you do the full domain, and just in case people aren't familiar, but you see on my DNS records here, I have a dot at the end, so example.com dot and acmedns.io dot. The dot just means the root of the DNS hierarchy. Depending on your DNS provider, you might or might not need to do that. Technically it's required, but some DNS providers figure it out without putting it in. So ACME-DNS improves security in a few different ways. One, the credentials that we're storing on disk are only for ACME-DNS. So they're no longer equivalent to our Namecheap account. They're no longer equivalent to our AWS tenant. It's just that one service that has nothing other than serves text records. And even though we're doing a CNAME, like delegating something to it, we're only delegating that auth challenge record to the other service, and so we're no longer allowing the credentials to be able to modify our A records or our MX records for where our mail points. So they, if the credentials get leaked, an attacker can't like redirect your website to their server, can't redirect your mail to their email server. Let's see. And the other cool thing is that this is not an all or nothing thing. Like we can set certain records to be answered by one ACME-DNS service. We could set other records to be answered by another ACME-DNS service. We can still do the provider base if we really wanted to. Like nothing is precluding anything else. This is purely a incremental optional add-on that is, in my case, recommended. And you can build it yourself into automating with this solution instead of other solutions over time. And then, unless you're running your own ACME DNS service, you don't need to have any internet-facing ports for this to work. So other than your ACME DNS service, like that would need to be exposed to the internet, but only the port 53, which Let's Encrypt will come and check that for the record. If this is like an internal-only solution, the port 443 doesn't need to be open to the internet. Just need to be open to the servers that are going to be requesting or that are going to be hitting the API to update those records. And one really cool thing is that if you're using this in like a corporate environment, the DNS admins, might not have, previously might be afraid to delegate automation to other teams because of these reasons where, one account or one credential is going to be kind of God mode for anything on a domain. And they were like, no, we don't want you automating anything against our DNS. It's, we don't want you to blow it up or get that leaked or anything like that. So by doing this, DNS admins, they can put that one CNAME in that points at another service, and then that service is what the non-DNS team is automating against. And so if you're going to be using ACME DNS, you can set up your own service, which is what I've done. I host one on my VPS. And you can either run it straight from the Git repo as a, compile it from the Go sources, or there is a Docker container. Now, the author of the program, again, Juna Hoikla, does host this available as a link from their GitHub. This is really, really great for testing. Like if you want to test this out, just with one domain, use the author's service. You set it up, test it out, and if you like it, run your own service. Then there's also this getlocalcert.net, which seems like it's a service more for helping developers that are doing local development get valid certificates for their laptop when they're developing something. And so, again, because we can delegate control on a per domain basis, those local developers, if they have like a testing domain that's dedicated to them, they can get that valid certificate for essentially corporate URL, but without having to give them full access to the DNS or the whole domain. And then the other part, like I mentioned, is going to be that you're going to need an ACME client. And so the two that I have a lot of experience with are going to be acme.sh. This is a collection of shell scripts that has a lot of DNS providers kind of baked in, a lot of plugins, and it also supports a lot of deploy hooks, so like pushing certificates to different appliance services. And so this one has, I don't know if it's first party, but it's in the official repo of ACME-SH, a ACME-DNS plugin. And so that just supports that out of the gate. And Traffic, which is a web proxy load balancer that's kind of container first. I'm sure probably people know more about it than me, but it's great for hosting with Docker because you can dynamically update the configuration of traffic based off the labels on another container. And so this has native support for ACME DNS as a DNS 01 challenge provider. And so both these projects will do automated that curl request and get those credentials. It'll automatically get a new one for every domain stored in a database, and kind of separate those out so that each certificate that you're getting is going to have a different set of credentials. And then there's a couple other clients that I'm not that familiar with, so like Cert Manager and Lego, Posh ACME. These all supposedly have native support for ACME-DNS. I personally haven't used them, but they're listed on the ACME-DNS project's GitHub as being compatible clients. Then the last two that I want to mention are going to be CertBot, which a lot of people are probably familiar with for another shell script that's automating certificates for Let's Encrypt. And CertBot, last I checked, still doesn't have a native plugin for this. So there's a couple different third-party plugins, and you'll just have to like evaluate which one you like the best, and you use that with your with CertBot. But it is possible. And Caddy, it looks like there is a first-party module for the ACME-DNS challenges, but it might not be compiled by default, so you either need to install another module or recompile. I'm not sure exactly how that software project works, but it's not in their core Let's Encrypt automation. And so another story time I kind of mentioned earlier, and that's at the beginning of May 2024, GoDaddy, without announcement, killed access to the API for any users that don't have that haven't purchased, I think, 10 domains or aren't subscribed to their like domain club premier subscription. So basically, if you're not spending enough with GoDaddy, you can't use the API anymore. And so a lot of customers were caught unaware, and lots of them were jumping ship to Cloudflare, and specifically because of their DNS. Their certificate automations, they can't update the records anymore, so they're out. And the thing that I would like to impart is that using a solution like ACME-DNS to delegate the automation records would have saved a lot of these people a lot of heartache, because one, in most cases, that DNS API going away, they wouldn't have been hurt by it. Like, their automation is elsewhere. So they could have kept using GoDaddy if they really wanted to. I don't know why they would, but they would have had to move. Or if they did change to another provider, Cloudflare or any other provider, their automations are already set up, and as long as they copy over those CNAME records, the automations will continue to work. So this would have saved a lot of people probably a lot of heartache if they had already been using a solution like this. But GoDaddy has always been shitty, especially with like their domain transfer locks, where like you got to wait up to 7 days before they actually release it, and then you're doing a go live in the middle of the night, whenever they happen to get around to it. So in conclusion, I just want to say that I think there's only one way to properly automate the DNS-01 challenge, and that's with this project, ACME-DNS. If you want to learn more, then the author of the project there's a pretty good blog post on the EFF website. And he also gave a talk at another conference a couple years ago, probably diving into a little bit more detail on kind of his motivation for developing this project and how he got into it. So thank you. So if you're looking for these slides, they'll be on my GitHub later today or something like that. I don't know. But thank you, everyone. Any questions? OK, thank you.